Have you ever stared down an armored chassis carrying an ultra-heavy gun barrel so massive that firing a single round threatens to tear every weld on the turret wide open? Discard those hollow, electronics-ridden modern vehicles. Today, we run a direct stress test on the most violent, heavy-loading configuration ever driven out of the Cold War foundries. Welcome to the FV4005 load test bed, an armored tank destroyer boasting the largest caliber, precision-machined gun barrel in the history of heavy industry. This steely 183mm monster of a barrel, outsizing even naval guns, was forged to anchor a single parameter to shred and vaporize the densest metallurgical armor plates with a single squeeze of the pressure-packed trigger. Its savage twisting power, an eccentric blueprint that shatters the conventional laws of mechanical engineering, and the classified metrics driving this assembly line are about to hammer a continuous shock wave straight into your eardrums. Cock the hammers. It's time to ignite. Rewind the gears of time to the 1950s. Amidst the high-heat blast furnaces of the Cold War, British forces hit a punishing load measurement obstacle. The enemy's ultra-heavy armored vehicle plates were being cast too thick, their metallurgical fatigue resistance too stubborn to break. To render these enemy specs obsolete, British mechanical engineers locked down a red-lined blueprint, welding together an armored block designed to output the ultimate crushing force. The FV4005 development line fired up with an extreme parameter. No matter how many millimeters of steel the enemy armor possessed, a single direct hit meant the entire mass of iron would instantly vaporize.
The armor-piercing rounds it's got. So they then decide that they need...
Reaching this load milestone, our crew wants to scan your data. From which coordinate or workshop yard are you anchoring your gauges to? Watch this video in your mental archive. Is there a specific armored configuration or weapons block that has hammered an indelible mark into your mind? Drop your specs in the comments below so the workshop crew can exchange notes and hoist those heavy metal memories onto the proving ground, alongside heavy machinery enthusiasts worldwide. The power core anchoring this machine's grit, and the exact mechanism that shattered every mechanical limitation of the FV4005 system, lies within the 183mm L4 gun barrel. Measure the tolerances yourself. Modern main battle tank blocks rarely dare to house anything beyond a 120mm or 125mm bore. Yet over 70 years ago, this ultra-heavy iron mass was already saddling a massive barrel scaled for a naval battleship. The dead weight of each cast Hesh high-explosive squash head shell redlined the scales at over 72 kilograms. When this ultra-heavy mass translates forward and slams into target armor, it bypasses traditional kinetic penetration principles completely. The high-pressure explosive compound squashes flat against the steel wall before detonating, driving a brutal shockwave that shears the armor plate apart from the inside out, pulverizing internal drivetrain components and turning the enemy block into worthless machining scrap. This axle-snapping crushing force hit absolute extremes, shredding every fatigue-resistant standard of mid-century metallurgy. While resting on a chassis capable of handling such rule-breaking force, the overall structural blueprint of the FV4005 block was asymmetrically crude. The ultra-heavy gun barrel was securely clamped onto the rugged chassis of a battle-proven Centurion tank block. Yet the turret walls were fabricated into a towering, boxy structure resembling a hand-welded tin shed. Measuring the specs on the highest output FV4005 Stage 2 variant, this massive turret enclosure was skinned with nothing more than a thin sheet of rolled steel gauging a mere 14 millimeters in thickness. This sheet metal skin was so thin that its fatigue resistance could only deflect small arms rifle fire. Why build such an asymmetrical loading parameter? The workshop designers calculated the blueprints inside out. The violent rearward kinetic recoil of that 183mm gun was so savage that adding heavy armor plating would overload the hull's suspension, snapping the leaf springs and shock mounts on the very first pressure release. This mechanical block was forged solely to anchor itself in long-range ambush, exert fatal pressure, and immediately engage reverse gear to cool down. Though packing the most violent mechanical compression in the yard, the FV4005 system was choked by fatal blind spots in its machining tolerances, causing it to permanently lose momentum on the test bed. The most glaring flaw was the oversized welded turret profile, which turned the vehicle into a massive target for incoming fire. Enemy spotters could easily lock down the coordinates of this looming iron mass from extreme distances.
Tanks, you're not going to have many of them, but there's enough there to supposedly cause...
A second metric failure lay in its catastrophic reload cycle. Even with the crew exhausting their physical endurance to chamber the rounds, this heavy block required nearly a full minute of grueling labor just to spit out a single shot. If the first pressure release missed its tolerance and strayed from the target, the loaders inside were effectively locked into a fatal pressure drop before a second shell could be rammed into the breech block. Furthermore, the recoil force was so violent that with every detonation, the shock absorbers were stressed to their absolute limits, while the shock waves bouncing within the cabin walls left the crew clutching their chests on the verge of blacking out. By the close of the 1950s, as electronically guided anti-tank guided missiles, ATGMs, rolled out of production lines, packing stubborn, armor-piercing capabilities into compact blueprints with precise target tracking. The custom-welded FV4005 assembly line was completely decommissioned. The raw mechanical torque of this heavy gun system had to drop its RPM, surrendering the proving ground to the highly responsive age of circuit boards. This ultra-heavy mass of iron was mothballed permanently before ever tasting the burning soot of actual combat, leaving a vacuum of missed potential for history buff mechanics. Right now, the sole surviving unscrapped FV4005 hull blueprint rests under static load at the Tank Museum in Bovington, England. Though its rotational power faded long ago, the FV4005 still cements an eternal milestone in heavy engineering. This massive blueprint stands as steely evidence of an era when raw human grit, radical stress testing, and the brutal endurance of the workshop masters forged an armored block that pushed human metallurgy to its absolute limits of raw violence.